In the previous video, we took a look at function annotations and particularly how they interact with function decorators. In this video, we'll look at class decorators, which are conceptually similar to function decorators, but open different doors. Class decorators work in the same basic way that function decorators do. A class decorator receives a class as its only parameter, and whatever it returns replaces that class. The return value doesn't have to be the same class or even a class at all, but it should be something that is meaningful when it's bound to the class's name. It's rarely useful for a decorator to return none. Also, like a function decorator, a class decorator can modify the attributes of a class or enclose the whole class in wrapper code. However, modifying the attributes of a class is effectively the same as modifying the class's source code, which means that unlike with functions, a class decorator can actually alter the structure of the decorated code, not just wrap it. Modifying class attributes is straightforward. We just use the built-in getAttribute, setAttribute, and delAttribute functions. In this example, we see a simple class decorator that makes the attributes of the decorated class readable through the square bracket syntax. And at the same time, make sure the class doesn't allow setting or deleting values through the square bracket syntax. While rewriting classes via decorators can be a powerful technique, it's not a complicated or surprising one, so there's not much more to say about it. We can also wrap up classes in their entirety. One common use for that technique is to replace a class with a factory function. Using a factory function as the interface to creating class instances lets us choose to return an existing object, if there's one we think is more appropriate than actually creating a new instance. Calling a factory function means give me the right object for these parameters, rather than give me a new object for these parameters. Let's take a look at an example class decorator that replaces the class object with a factory function for instances of that class. We'll assume that any two instances that were created with the same parameters should actually be the same object. In this example, we're using a weak value dictionary to keep track of the existing instances of the class and what parameters that were constructed with. That doesn't have anything to do with class decorators per se. Instead, we're doing it because we don't want the cache to prevent the instances from being garbage collected. That's a good practice whenever we make a factory function that keeps track of the instances it creates. Another bit of good practice that we're demonstrating here is that we've assigned the class itself as an attribute of the factory function. That means that code outside of the factory function can still access the class object if it really needs to. So let's take a look at our factory making decorator in action. Notice that the thing named unique is in fact the factory function that was created for the unique class, rather than the unique class itself. The actual class ends up being named unique.type. Also, notice that U1 and U3 are not just equal, they're actually the same object. Meanwhile, U2, which was created with different arguments, is a different object. Now we're going to take a look at something really wild. The syntax we use for defining classes is pretty generic. It could be used to represent all sorts of different data structures. So why not use class decorators to transform class definitions into objects of various types? By doing this, we can achieve a sort of sideways declarative programming paradigm. For our example, let's say we want to connect to a SQLite database and create some tables in it if they don't already exist. We can make Python's class syntax work for us as a convenient way of expressing that idea. We want the usage to look something like this, where the class structure and attributes provide the information that's needed to construct and configure a database connection for us. The end result should be a connection object, which we can use to issue queries according to the Python database API. There are a great many details that are ignored or handled simplistically by this example, but it captures the general idea. The class objects that Python creates automatically when it's evaluating these statements are used to provide structured data input to the decorator called database and then discarded. The database decorator returns an open Python database API connection object, not a class of any sort. In this video, we saw how the class decorators work exactly as function decorators do, but because they're operating on classes, the possibilities are very different. We saw how to modify classes, wrap them, or even replace those using decorators. In the next video, we'll look at a different way to programmatically modify classes using metaclasses.